linear equations in two variables. In the last lecture, we have seen what is meant by linear equation in two variables. Also, we have seen what is meant by the solution of linear equations in two variables. We have studied one method of solving two linear equations in two variables. That was method of by equating the coefficients. Today we are going to see another method. This is method 2, that is solving solving linear equations in two variable by substitution. So here, first thing what we have to do, that out of the two given equations, select one. Now here you are having choice which one to be selected. I will show you. Selecting any equation, you are getting the solution, but for your convenience you can select the suitable equation. Say for example, if we are doing question number 2, sub question number 2 on your text page 5. This is x plus 7y is equal to 10 is your equation number 1, and 3x minus 2y is equal to 7. This is your equation number 2. Now I said here that out of the two given equations, select one. So suppose you have selected first equation. So x plus 7y is equal to 10. Now you have to write x in terms of y. Okay. Then second, write one variable terms containing one variable, one of the two variables on LHS, and transfer all other in all others to right hand side. Second step is write term containing one of the two variables on LHS and transfer all other terms to RHS. So here, suppose I keep x on LHS and 7y and 10 on RHS. So 10 and this 7y is on left hand side, so that becomes minus. X is equal to 10 minus 7y. Now this value we have to substitute in the other equation. 3, this value of one variable we have to substitute. That's why this is called as substitution method. Substitute in other equation. So this other equation is 3 into x. X I have found out to be 10 minus 7y minus 2y is equal to 7. This I am getting from 2. I am writing here from 2 so that the reader can refer to what 2 says 3x minus 2y. 3x minus 2y is equal to 7. And here I am writing 3, and instead of x I am writing as 10 minus 7y. I am writing here therefore means I am using this also. And now if I solve this, I am getting 3 into 10 is 30 minus 3 into 7y. 3 7s are 21y minus 2y is equal to 7. Now collect the like terms. Therefore 30 and minus 21y and minus 2y. Minus 21y and minus 2y. When both are minus, when both of them are having same sign, you have to add them. 21 and 2 is 23y and give the same sign. So this will become minus 23y is equal to 7. Now next is keep the terms containing the variable on one side. Fourth is keep the term containing a variable on one side and transfer all other terms to other side. Keep the term containing a variable on one side and transfer all other terms to other side. So here minus 23y is a term containing as a variable that should be on one side and all other terms on the other side. You may keep this term on left hand side or right hand side as you please. So minus 23y is equal to 7 is on the right hand side, it will not change, and this 30 transposed to other side, this positive will become negative, and therefore minus 23y is equal to, now you have to operate 7 and minus 30. 7 is positive and minus 30 is negative. When you are adding, this is algebraic addition. When you are adding two numbers, one is positive, other is negative. From the greater number, you have to subtract the smaller number. 30 minus 7 is 23 and give the sign of the greater, that is greater is 30, sign is minus. So minus 23y is minus 23. Okay. Now next is if the term containing variable is negative, we may multiply by minus 1 both the sides. This also can be eliminated. This fifth step can be omitted, but it is better not to commit a mistake. Any ordinary students also can do without mistake. So here 23y is minus sign, so I am multiplying by minus 1. So minus minus will become plus 23y is equal to, here also multiplying by minus 1, I am getting 23. Okay, and now divide both sides by coefficient of the variable. Divide both the sides by coefficient of the variable. So here y is the variable, the coefficient of variable is 23. So divide both sides. 23y divides 23, and here right hand side also divides by 23. So this 23 cuts, and therefore y is equal to 1. So this is the value of one variable. Okay. Now here what we have done, equation number 1, 2. So this can be said as equation number 3. And this value we have to put in any equation. You may put in equation number 1, or you can put in equation number 2, or you can put in equation number 3. This is 3. Okay. Actually this is most convenient. Instead of calling this 3, this I am calling as 4. So you have to put this value in the equation number 3. This is 7. Put this value. In equation number 3, where we have written one variable on LHS. Here, out of the two given equations, select one. Write terms containing one of the two variables on LHS and transfer all others on RHS. This value of one variable we have to substitute in the other equation. So here we have to substitute this. So this value y is equal to 1, we have to substitute. We can substitute in any equation, but it is advisable to substitute in 3 because here x is directly obtained, and therefore x is equal to 10 minus 7 and y is 1. This is from 3. That is 10 minus 7 into 1 is 7. 10 minus 7 is 3. Therefore, x is equal to 3. This is equation number 4. This is 5. From 4 and 5, x is equal to 3 and y is equal to 1. That is, ordered pair xy is equal to ordered pair 3, 1. When we say two ordered pairs are equal, it will mean the first element is equal to, the first element is equal to the first element of the ordered pair, and the second element is equal to the second element. So x is equal to 3 and y is equal to 1. This is the solution. If you want to check it, so what value we got? X is 3, y is 1. So this will become x is 3 and y is 1. 7 into 1. 3 plus 7 into 1 is 7. 3 plus 7 is 10. So this is correct. And here x is 3. So 3 times 3 minus 2 times y is 1. So this is equal to 3 3s are 9 minus 2 1s are 2. 9 minus 2 is 7. So this is also correct. Both the equations are satisfied. Our answer is correct. Now, same thing I am doing for your satisfaction here by selecting some other thing. Okay, Here what was the first? Out of the two given equations, select one. Which one I had selected here? X plus 7y is 10. So I had selected 1. Okay. Now I will select 2 and I will show that the same answer comes. In examination, you can do by any method. 3x minus 2y is 7. 3x minus 2y is equal to 7. This is equation number 2. 3x minus 2y is 7 from 2. Okay. Now what they are saying, second step is, out of the two given equations, select any one. Then second is, write term containing one of the two variables on LHS and transfer all others to RHS. So here I can say, either I can say that 3x is equal to 7 plus 2x, or you can say minus, sorry, not 2x, this is 2y. So 3x is equal to 7 on right hand side will remain 7 and minus 2y transpose to right hand side becomes plus 2y. Okay. Now here one step I have forgotten to tell you. Here write terms containing one of the variables on LHS and transfer all others to RHS. The value of one variable, to get value of one variable, divide both sides by coefficient of variable on LHS. This would have been written here as one step. Now here I have to divide by 3. Therefore 3x upon 3 is equal to 7 plus 2y upon 3. Here 3 gets cut and therefore I am getting x is equal to 7 plus 2y upon 3. This is my equation number 3. Okay. I have started with equation number 1. Equation number 2. We have to write this first everywhere. In examination, this step I have omitted just now, but this you have to write equation number 1 and equation number 2 you have to write first and then write the third. Now what we have done, this value of one variable we have to substitute in other equation. So here I have started with equation number 2. So I have to substitute this value in equation number 1. Equation number 1 is x plus 7y is 10. Okay. X plus 7y is equal to 10. This is from 1. Substitute value in equation, value from equation 3 into equation 1. Therefore, here x, instead of x I can write 7 plus 2y upon 3. 7 plus 2y upon 3 plus 7y plus 7y is equal to 10. Now to solve this equation, I am having a number 3 in denominators. So I will multiply by 3. So this multiplied by 3, first term multiplied by 3 gives you 7 plus 2y upon 3 multiplied by 3 cuts. This also I am multiplying by 3. So 7y multiplied by 3 gives you 21y, and 10 multiplied by 3 gives you 30. You may write here on multiplying by 3. Now what we have to do? Let us see. This right term containing one of the two variables on LHS and transfer all others to RHS. Divide by the coefficient dividend. This value of one variable we have to substitute in other equation. Yes, we have done that. Now keep the terms containing a variable on one side and transfer all the terms on the other side. So here, this we can simplify. 7 plus 2y plus 21y is 23y is equal to 30. Now keep the term containing one variable on one side. So 23y is to be kept on one side. 30 is already on the right hand side. It will remain like that. And transfer to other side. So this becomes minus 7. Now this you can simplify as 23y is equal to 23. Divide by the coefficients of y. Therefore, y is equal to 23 upon 23. I have divided both sides by 23. And therefore, y is equal to 1. Let us see what this says. Keep the term containing a variable on one side and transfer all the terms on the other side. This we have done. If the term containing a variable is negative, we may multiply by minus 1 both sides. This is if it is negative. We didn't have a negative, so this is also done. Divide both the sides by the coefficient of the variable. We could have divided here itself without making it positive. We could have divided both sides by negative also, but this is better. Okay. Now divide both the sides of the coefficient of the variable. We have divided by 23. Put this value in equation number 3, where we have written one variable on LHS. That we are going to do now. So here, equation 3 is x is equal to 7 plus 2y upon 3. There we have to put this value. Therefore, x is equal to, you may write this 7 plus 2y, 7 plus 2y upon 3. If you are writing this therefore is not required. This you can say from 3. This therefore refers to when it is continuation of the previous. This we have starting as this. Therefore, x is equal to. Now this you have to substitute. This you can say equation number 4. So x is equal to 7 plus 2 times y means 1 upon 3. This we have made use of by 4. This is equal to 7 plus 2 into 1 is 2 upon 3. 7 plus 2 is 9. 9 upon 3, that is 3. Therefore, x is equal to 3. This is my equation number 5. From 4 and 5, from 4 and 5, x is equal to 3 and y is equal to 1. That is, xy is equal to, x is 3, y is 1. So x is 3 and y is 1 is the solution. What we had obtained here, x is 3 and y is 1, same solution we get. So this can be done 4 ways. Okay. 4 students can do it in 4 different ways. Because out of the 2 given equations, select one when I say. Students may select equation 1 or equation 2. So there are 2 ways. And then write term containing one variable one of the variables on LHS and transfer the other on RHS. When I am saying this, a student may keep x in one left hand side and y is at right hand side, or he can put y on left hand side and x on right hand side. So there are two ways again for that. So total 4 ways. I have shown you 2 ways. You can try all other remaining ways also. So if you want practice, you may do most of the sums by different methods. It will give you practice.